So good evening everyone. So welcome to this interactive session week 2 for the course on Introduction to Multimodal Urban Transportation Systems. So the course instructor is Swarkopal Goswami from IIT Kharagpur and myself Suman Ganguly. I am a research scholar at IIT Kharagpur. So am I audible? Can you confirm that I am audible? So am I audible to you, Rajendra? I am audible? Okay. So let's continue with the session then. So I have designed I think 11 questions for this week 2. So maybe first you can try to answer these questions, then maybe I will discuss each of these answers or each of the options one by one, right? So the first question is regional transportation systems deals with. Is it deals with intra-city trips or long distance trips or both or neither of those things? So maybe in the chat box you can give the answer. You can at least attempt. If it is wrong also, then also it is alright. So what is regional transportation system? What is regional transportation system? In the chat box you can answer. So okay, so let's discuss then. So based on the classification, there are mainly two types of transportation systems, region wise. So first is urban, second one is region, right? So urban transportation systems deals with intra-city trips, right? So within the city, whatever the trips are occurring, right? So they are dealing with intra-city trips. But what are the regional transportation systems then? So regional transportation system means your rail, which is connecting two cities within a state or maybe from a city of a one state to the city in another city. That is also called regional transportation systems. Right? So mainly it deals with the long distance trips, not the intra-city trips. So those are urban transportation systems. Right? So here the correct answer would be this B. Right? So also if you have any queries you can answer along the way, right? So then the second question is, what is the one-way distance between two terminals along the line? Here line means any transit lines. It can be bus, it can be also rail, right? So what is the one-way distance between two terminals along the line is called? Is it transit network? Is it line length? Means transit line length obviously. Is it transit line or is it the network length? So you can try at least, then maybe I will start discussing it. So what is the one-way distance between two terminals? Suppose a bus leaves from one terminal and ends at another terminal, right? And in between there are intermediate bus stops. So that length is what? Is it line length? Is it transit line? Is it network length? What? So it is line length, that is transit line length. So why it is transit line length? Because other options like transit network, so it is just saying it's a network, it is not saying about the distance, right? So here the question is one-way distance between two terminals. So A is not the correct option, right? So then what is the transit line? So it is just a line, whatever the line is exists. So it is just a line, right? So along a transit line, along a road network, what is the transit line? means what is the specific routes, right? So it is also not the distance measure, right? So the last one is network length. So network length consists of all the routes, right? In a region, whatever the bus routes or metro lines are there, it considers all the routes. So it is a line length. The correct answer is line. Right. So third question is, what is the maximum number of spaces for passengers a transit unit can accommodate? So what is the maximum number of spaces for passengers a transit unit can accommodate? So you can try to answer that in the chat box, then maybe I will explain each of these terms. So you take some 10-20 seconds to answer. If it is convenient, you can answer in the chat box. Okay, so let me discuss then. So what is vehicle capacity? So vehicle capacity, so what is a transit unit? So transit unit is basically consists of many vehicles, like a set of n number of vehicles consists a transit unit. So if you see a rail, so rail have multiple bogies, right? So each bogie can be considered as a one vehicle. So in case of bus, normal bus, it's a one vehicle only, and that is also a one transit unit also, because here n is equal to 1, right? So in number of transit units, here only one vehicle is there. So then the maximum number of spaces for passengers that a TU can accommodate, what is it? Is it vehicle capacity or is it line capacity? So what is vehicle capacity? Vehicle capacity is the maximum number of vehicles actually a TU can accommodate. So then why it is not line capacity? So line capacity basically considered as the capacity of that line, that is the maximum number of spaces available for the passengers per hour. It is not a particular vehicle wise maximum number. It's a number that is based on the maximum spaces available per hour, right? So that is line capacity along a particular transit line. So then what is utilized capacity? So utilized capacity is actually whenever you are traveling during peak or off peak hours, so what is the maximum number of passengers actually transported from one place to another place per hour, right? So its line capacity is what maximum number of spaces are available, and what is the utilized, what is the space that are passengers utilized during a trip, right, per hour obviously. So what is then offered capacity? So offered capacity is what is the, so suppose in an hour at a particular route there may be 4 vehicles like 4 vehicles that may be like based on that infrastructure, there may be only 4 vehicles that can run along a route, right? Say a bus, after 15 minutes a bus can run, right? So starting from 12, then maybe suppose it is starting from 12, right? 12 in the noon, then the next bus is 12:15, then the third bus is 12:30, then the next bus is 12:45, right? Then the last one is around 1, right? So there are 5 buses, 1, 2, 3, 4, 5. So in a 1 hour there are 5 buses that maximum can run. So what are the line capacity then? So suppose per bus there are 40 seats. So then 40 into 5, there are 200 is the maximum space that are available, right? So then what is the offered capacity? So suppose operator design in that hour, because maybe it's a lean hour or it's a off peak hour, maybe he is offering only 3 buses per hour, but the maximum capacity is 5 buses per hour that can run along a transit line. But no, he is giving that I will provide 3 buses per hour based on my estimation of passenger demand, right? So that is the offered capacity, actual space that has been provided per hour by the operator. So here the correct answer would be vehicle capacity, right? So rest of them are calculated per hour. So then capacity utilization factor can be greater than 1. So what is capacity utilization factor, if I would ask? So if I can go to the previous slide, so the that is the ratio of utilized capacity by the offered capacity, right? So the question is, if your utilized capacity by offered capacity, right? So is it greater than 1? Is it, the statement is true or false? So then in the numerator it is what? It is your utilized capacity, and in the denominator it is offered capacity. So suppose is it possible that your actual utilized capacity is greater than your offered capacity? No, generally it is not possible, but it may happen in the scenarios where you have, like say you are saying that I will provide only 40 seats, but you have not accounted for the standings, because there are many passengers who will stand also. So in that case it may exceed, but usually it does not exceed. Means it cannot be greater than. So it can be greater than, or no, it cannot be greater than in usual cases. So then the next question is, what is operating ratio? So if you remember the lectures also, it is based on that three kind of performance measures, right? So first one is the operational measures, second one is the financial performance measures, and third one is the quality of service measures, right? So there are three types of measures. So then what is operational performance measures? So during bus operation, like now a bus is starting from 8 from the terminal, and it will end like around 9. So it's a 1 hour trip. So during this operation, what are the performance measures that one should look for the bus performance? So basically operational performance measures can be number of passengers that are traveling for that particular trip. It may be also the total passenger kilometer. So what is passenger kilometer? So each passenger, how much kilometer they are traveling. So maybe some passenger are traveling 2 kilometers only, so maybe 2-3 stops. So some passengers are traveling suppose for 14 kilometers, right? If it's a 20 kilometer long trip, and some passengers are entirely covering the route, like they are traveling for 20 kilometers. So that is called the passengers kilometer. That can be a performance measure while bus is operating. Then what is the fuel consumption? It is also a measure, because you need fuel to run a bus while it is in operation, right? So that is also a kind of operational performance measure. So then the next one is accidents. Also while the bus is operating, there could be accident also. So those things one should take care of while evaluating the operational performance measure. So then what is financial performance measure? So it is based on the benefit cost analysis, right? So what are the benefit and what is the cost of operation and cost of maintenance, and also the cost of running also, right? And also the purchasing maybe sometimes. What is the initial cost, that is called. So then that is called financial performance measure, right? So what is quality of service performance measure then? So it is basically attributed to the passengers, right? So quality of service is always the passenger's point of view. So what is the time that our passengers are waiting at a particular bus stop? Then what are the if that service is reliable or not. So what is reliability? Reliability means the one time performance of the bus, like if bus is following the schedule or not. If bus is not following the schedule, then the passengers waiting time might increase. So that is their quality of service. Then affordability, in terms of fare, is it cheap or not, if bus operator or government is providing the subsidy or not, right? So those are the quality of service performance measures. So then what is operating ratio? So actually operating ratio is the revenue earned from the total revenue earned by the agency by the total cost. So here it is not only the fare, but also the, like if bus is like bus is giving you the like using the app, bus is providing you the time of arrival at different bus stops. So using that also bus may earn revenue, right? and also during different advertisements and different activities related to the transport, bus may earn revenue. So that's the total revenue and the total cost. So then the operating ratio is what? Financial performance measure, not the other two measures, right? So then the next one is what are policy headways. So normally what is a headway? So headway is nothing but the time difference between dispatching of two buses. So suppose you have a terminal A. So first bus is starting from 10, right, and the next bus is around 10:15. So what is the headway then? Headway is 15 minutes for that two buses. And if the next consecutive bus is departs from 10:30, so then your headway is 15 minutes, right? So then what is policy headway? So policy headway, so suppose you have a route where the passenger demand is less, right? So like during the off-peak hour also the passenger demands are usually less. So in that case what happens is that operator wants to give less service or less number of buses or less number of frequency of buses to that particular route because of the lower demand, because if the passengers are low then the revenue earned will be very less, right? So but the policy headway is a kind of threshold where a minimum bound has been provided for the service frequency to meet the minimum LOS for passengers. Suppose you have a low demand route and you are providing one service per hour. So for a particular passengers who came to a bus stop around 10, he needs to wait almost 1 hour to get the next bus. If it misses the bus around 10, if it is coming on 10:05, he came to the particular bus stop, then he needs to wait for how much minutes? 55 minutes. So there it is not providing the minimum LOS of passengers. The waiting time is very high. So the policy headway is restricting that. Policy headway is a kind of threshold that no, in an hour maybe you should provide 3 services at least, even if the demand is low. So that's what a minimum policy headway is, right? So then what is the correct answer? So maximum service frequency, no, obviously if it is a high demand route then your service frequency will be maximum, right? So then it is what? It is based on the minimum service frequency, right? So then the next question is how do you calculate the fleet utilization factor? So okay, so what are these NF and NM? So N is suppose you have that number of vehicles for the regular peak hour service, because generally peak hour the demand is very high, so you need more number of buses than the off peak hour. So then in the peak hour suppose you have n number of vehicles, right? So it is called N. So what is NR? NR is the reserved vehicle. So why you need reserved vehicles? In case of vehicle breakdowns, in case of emergency, any kinds of, in those kinds of situation you need some reserve buses so that you can, and if your one bus is not working, so you give another bus to replace that bus so that your passengers are not affected, right? Since it's a public transport, so passengers should not be affected. So it is NR. So then what is NM? NM is the buses which are right now they are under maintenance or they are old, like that. So those fleets are NM. So the total fleet is what? NF. NF is N plus NR plus NM. So what are the total fleet? So what is the fleet utilization then? So like are we utilizing NM? NM is maintaining. So we are not utilizing that NM. So we are utilizing the regular service that we are providing and the backup buses, which is the reserve vehicles, right? So then your fleet utilization factor will be N plus NR by NF, right? Because NF is the total number of okay. Okay. Okay, I will start even like this is also the session has been recorded. So if you have any questions, you can you can write on the chat box, right? Even if you are not understanding anything due to your network issue, you can write it in the chat box. So then the correct answer would be this D. And also you can try to answer before I start discussing and saying you that what is the correct solution. You at least try once, because since it's an interactive session, it is designed for the interaction. So it is not a pre-recorded thing, right? So if you want to ask something regarding this while I was discussing, then you can also ask, right? So maybe I will go to the next question. So then the question is, higher frequency of service always leads to low waiting time of passengers. Is it true or false? So you can guess what is frequency of service. Frequency of service means the number of buses running in an hour, right? And how it is related to the waiting time of passengers. You can see the picture what is here, right? So this picture depicts something. So maybe then you may correlate and you can try to answer, right? So these are the uniform headways. Buses are running 15 minutes. At a particular hour, there are 5 buses. Right? Here also at a particular hour, there are 57 minutes, 158, 59 and 60. So there are 1 hour there are 5 buses, right? In both cases. So your answer is true. So it is not true actually, always. So let me explain. So what is frequency then? Frequency of service is nothing but the number of buses that is provided, right? So suppose it's a 60-meter thing, right? 60-meter time, 15, 15, 15, 15. Here also 57, 1, 1, 1. So 60. So 60 minutes, here are also 5 buses, there are also 5 buses, right? There are running 5 buses in both scenarios. So then suppose a passenger is waiting here at the start, right? So then initially he got a bus this, right, here, because it is the route. If you consider this is the route, right? If you consider that this is the route, so here a passenger is waiting, right? So and this bus goes around 57 minutes ago, right? So a passenger is availing the service here. So then for 57 minutes there are no buses, right? Because the headway is this. So there are no buses. So then the waiting time of the passengers, because passengers will accumulate during 57 minutes. Are you getting what I am trying to explain? So your headway increases 57 minutes. Then there are multiple buses. So isn't it will increase the waiting time if you compare this scenario and this scenario. So the passengers coming in 15 minutes, is it not, it is actually less than the passengers that will accumulate at this bus stop during 57 minutes. It is more number of passengers. Yes. So it is not always that, although frequency and headway is a related thing, but headway is a another important measure that you want to consider during your providing, while you are actually providing the service, right? So your uneven headways will actually leads to instability in your services and leads to increased waiting time and also the corresponding deterioration in the level of service, right? So I hope it is clear now. So it is not always true. So it is not always true. This is the correct answer. It may be true if it is even, but in this scenario it is not true. So it is the number of transit unit per hour. So then what does one mean by program speed? So there are multiple speeds that you already know. There are station to station speed, then there is operating speed, then there is running speed, then also there is terminal speed, then there is program speed also, right? So what is program speed? So maybe you can attempt, because last time also you attempted, so it is good that you attempt. Then I will start explaining. D. Okay, Rajendra said D. Also, Prashant also you can answer. At least you can attempt also, like Rajendra. Okay. C. You are saying C. Okay. So there are mixed answers. So, then let's discuss each and every points. So then, what is the speed of travel offered to the public? So what do you mean by offered to the public? So suppose you are uh, you are availing a bus which is running during peak hour. Right? So then obviously your operating speed will be low, right? What is the speed that the vehicle is traveling? It will be low compared to the morning hour or the lean hours, right? So then that is the speed, actually it is actual speed that is offered to the public. So it is called the operating speed. Right? So it is called the operating speed. So then what is the average speed of a transit unit for a complete round trip on a line? So it is going for A to B and then it is coming B to A. So it is also considering the waiting time at the terminals, right? So that's called the complete round trip, because it is started, then it will wait, then it will again leave the service, right? So it is called a kind of cycle speed. Right? Then what is the third one? Third one is the average speed of a transit vehicles achieve from leaving one station to arriving to the next one. So what is this? If at a particular bus stop, bus starts departing, and the next consecutive next stop, which is the immediate next stop, so bus is stopped. Bus just stopped there. So what is the speed between this point to this point? So it is nothing but a running speed, and if you consider leaving and arriving, so it is actually here it is not a station to station speed, because it is leaving from one station and arriving at next one, so it is running speed. So this is not true actually. It should be running speed, right? Because station to station speed is what is, it is leaving from one station and the leaving to the another station, from one to another. So that is called station to station. It will calculate the dwell time, that is the waiting time of the buses at the bus stop to serve the passengers, right? Because passengers will alight and board, right, in the bus. So that has to be accounted also in station to station speed. So then the fourth one is the speed that the transit vehicles can operate, meeting the standards of safety, comfort, economy and performance. So each of the points has its own meaning, I can say. So suppose in the morning a bus is traveling with no apparent traffic, but you know that bus will come at a intermediate bus stop around 6:50, right? But since it is during a off peak, so bus can reach at the station around 6:10. But then either the bus has to wait at the bus stop for 5 minutes, minimum for 5 minutes, or the bus should slow down and reach to this destination. So the second one, or the latter case, actually is operating. So the basically it is programmed at that maximum speed. So this is the maximum speed you can achieve. It is not the capacity of the vehicle. Maybe vehicle can run 100 kilometers per hour, but the program speed, if it is 80, then the maximum speed it can attain is 80. And also this program speed is not only about the schedule, but it also regarding the safety, because if it is a rash driving scenario for a public transport vehicle, then people won't be availing the service. So here our focus is to please the passengers, right, and to provide comfort to the passengers, right, provide the safety to the passengers. Also, if it is running at 100 kilometer per hour around the urban area, so along it is not the urban expressway, but maybe a subarterial road, which is a lower mobility kind of road. So there also comfort may be hard. So people won't be comfortable also. So then economy, obviously if your speed will be high, then it can be related to the passengers. First the passenger discomfort may be increases, so passengers will not availing the service. so your revenue will go down, so it will impact the economy also, right? And then the performance, so here performance you can assume the schedule, that is the performance, on time arrival or those kind of things, right? So then the correct answer would be D. This is the program speed that will be set by the operator. So then what is stations to station travel time? Stations to station travel time, I already discussed, so I think you would be able to answer. So can you try to answer in the chat box? I already explained actually in the last in the ninth question. So is it equals to operating time? Is it difference between running and dwell time? Is it the sum between summation between running and dwell time? And then is it the summation between running and operating time? So what it could be? C, you are saying. Okay. Then also Prashant. So what Rajendra is saying, it is sum of running time plus dwell time. Okay. So then Prashant also. You can also take a guess. No issues. So what is operating time? Operating means while bus is in operation for a particular trip, when the bus is in operating condition. So while bus is running along a particular road for a particular trip, that is called the operating. So operating time consists of it is consist of the stations to all the total time for a bus to start from a particular terminal, that is the original terminal, to the destination terminal, that is called the operating time, right? So then what is difference between running time and dwell time? So that itself, this option doesn't make sense, right? Because running time is what? Running time is between, if you have this stop to stop, if buses leaves here and buses reach to the means start from A or maybe reach to the next stop, that is B. So it is the running time. Buses, it is not accounting for the stop, that is dual. Dual means the time taken by a bus to serve the passengers, right, at a particular bus stop or at each bus stop. So then the difference doesn't make sense. So then what is sum of running time and dwell time? So basically it's a station A and it's a station B, right? It's not a terminal. If it is a terminal to terminal, then it could be an operating time, but it's a station to station, right? So that travel time is nothing but this option C. So then also what is sum of running and operating time? So I already mentioned you what is operating time and what is running time. This is also doesn't make sense, right? Because you cannot sum a running time to the operating time. Operating time is already the sum of all the station to station time. So if you have suppose 5 stations, so if you add consecutive 4 values between those stations, means travel time values, so that will give you the operating time. So this is so. So then the next question is, what is the type of bus stop placement and bus stop design in the following 2 figures? So there are 2 figures. First you need to answer the type of bus stop placement. So is it near side, is it far side, is it mid block? And the second is, what is the bus stop design? Is it open bus bay, is it curb side, is it queue jumper bus bay? So that for the 2 different these figures you need to answer it. Means there could be 2 different options also, right? So maybe I did not mark it. Maybe you can consider this is figure maybe small a. This is maybe figure small b, right? So like you can try to answer first, then I will start explaining. So this is like I am writing this using the mouse, that's why the A is like that. So it is A and it is B. So Rajendra and Prasant, you can actually try to answer. So you see bus is running from this to this. So we have our left hand traffic rule, right? In India, uh, like in the US or different cities, if you found that there are right hand traffic. So here our bus is running on the left if it is going to this direction. Right? So you can try once. That what is near side, what is far side, what is mid block. Based on that, and I think you are getting this is the bus stop, right? This is the bus stop. This is the bus stop. This is the bus. This is the bus stop. This is the bus stop. This specifying that it's a bus stop. So please try to attempt at least. If it is wrong, it is wrong. No problem. So it's a discussion only. So you can attempt. I will give you some more time to see. Oh, Rajesh is saying D. So tell me D for which one? A, figure A, this one or this one? These are different. These are actually different answers. Prashant also saying 2 for which one? So like for first figure A or first for the second figure B? No, you are confused maybe. So first is the bus stop's placement, right? So where the bus stop is placed? So bus stop is placed here, and bus stop is placed here, right? So for bus stop placements there are two answers, and for bus stop design there are two answers. So maybe let me simplify for you. So maybe you tell me the bus stop placement for this scenario. Is it near side, far side or mid? For this first A, first this figure, this is the bus stop, near side, right? Why it is near side? Because this is the intersection and it is on the near side, right? It is not on the far side. So now tell me for this second figure. Mid block, right? Why it is mid block you are saying? Because it is far away from the intersection, right? It is not here and it is also not here. So it is in the mid block of this link. So this is a link and it is situated in the mid block, right? So now tell me for each of the figure what is the bus stop design. So what is the bus stop design? Is it open bus bay? Also you know what is bus bay, right? And what is curbside bus stops? And what is queue jumper bus bay? So there are three options. Please try to answer. Okay, you don't understand. Okay, then let me discuss. So what is curb? Do you know what is this term called curb? So curb is this, right? So if you have a carriageway, so it is like suppose you have a carriageway and on the side you have a pedestrian footpath. So those are not at the same level, right? So there are some height has been provided, right? So that is the curve we are saying, right? So at the curve side means it is at this side. So then for the both two figures, so it is on the curve side, right? And then what is, you could say that what is open bus bay then? So the bus bay is like that. So if you have this and this, suppose road, right? So if you have a near side bus stop and bus stop is like that, right? So this is called the bus bay, right? Are you getting the bus bay? So there are additional places for the buses so that the other vehicles does not get disturbed by the bus, right? So then for the first one it is near side and curb. It is near side bus stop and curb side stop, right? Based on the placement and design. So it is B. And for the second one it is mid block and curb side. It is D. Right? So is it clear? From who is talking, I don't know. Maybe for Prashant and Rajendra it is clear, right? So I hope it is clear. So maybe. So then the next question is, which of the following is an operational performance indicator? So what is operational performance indicator? I already mentioned that there are three performance indicator, right? Operational, financial and the quality of service. So operational means while the bus is operating, right, along a particular route. So then, and the financial means it is related to benefit cost analysis, right? And third one is quality of service. It is solely depending on the passenger's point of view. So first you attempt to answer it in the chat box, then I will discuss each of these options one by one. So which of the following is an operational performance indicator? C. Okay. Prashant told that it is C. So then Rajendra. Rajendra also, you can answer. Okay, then I shall discuss. So then the first one is fare box ratio. So from the name itself, fare, we know that it is not an operational performance indicator, right? So it is a financial performance indicator. So what is financial performance indicator? Fare box ratio means. So it is what is the sale of tickets? Maybe during an hour or maybe during a period. So what is, or maybe for a particular trip, what is the sale of tickets? And then what is the operation cost? So operation cost might include the cost of the petrol or diesel, whichever the buses are using, right? And also sometimes it may include the maintenance cost also. So this is the fare box ratio. So then what is the passenger waiting time? So already I mentioned that the quality of service performance measures, they are basically directly related to the passengers waiting time, right? So if the like that is not an operational performance measure, right? Then what is stop bus ratio? So per bus, what is the number of stops that are allocated? So stops may be the conductor, the bus driver, right? So those are the stops. So it is basically during a operation, if you see for a particular trip how many stops are there per bus, that is of importance. So it is operational performance indicator. So what is affordability then? Affordability is also related to the passenger. So if the fare is significantly higher or fare is subsidized, so that what is means. Right? So the correct answer is, which of the following is an operational indicator? It is C. So Prashant, you are actually that time right. So then thank you. So it is the end of my presentation. So maybe if you have any doubts for this particular session from the lectures as well as from this session, you may try to answer. So that I might not be able to address right now. I might need to see it, maybe so what is the problem you are saying? Tell me. Only grid type, nothing is mentioned. In question number 2, you are saying 12, 1, 2. Okay, I need to see it. I am not aware of this, right? So maybe in the discussion forum, maybe you will get the answer, right? Discussion forum, I will try to talk to them, and then maybe in the discussion forum. Tell me other doubts. Okay. And okay, I will I will like you will get the answer in the discussion forum, right? 12 question you are saying, no? A and C options are same. Okay, okay, that will be addressed. Any other queries or anything before we wrap up the session? No, for okay, okay, Rajendra and Prashant. Okay, then thank you. We shall meet in the next week for the week 3 interactive sessions, right? So thank you for joining.